Right, let's look at exercise 1 then. So the thing is here, we enter an amount. We enter a code, and it has to have 8 characters. So we use the length for that. Yeah, okay, so use the length for that. And then we stop with a Sentinel loop. So we keep going until the person puts the number of students in a class is a negative number. And we count the sections as we go. So we got a counter in our loop. The loop has a counter in it, but we're not using the counter to control the loop. The loop is controlled by the Sentinel. So that means that we're going to set the Sentinel before the loop, and then we'll check the Sentinel again at the end of the loop. The other thing is that we've got a total that we're calculating as we go along. We could do an average on this too, but yeah, okay. Let's go with a flow chart. No, it wouldn't be D2L. What am I doing here? Draw. I suppose it's possible to have. So we're going to call this lab 10, exercise 1. I'll try and do this as quickly as I can with you, so we have time to sort of finish. So I hope it's okay. You can follow along, and as I said, you can watch the video if you want to afterwards. So I thought there was a grid thing here. Never mind. Anyways, so the first one is the start. AX1, what am I doing here? Okay, make that smaller. So what we're going to do with this is we're going to get the course code. That's not going to control the loop. So we can just get that straight up, I suppose. And okay, so, but the course code, if there's an error in the course code, we have to say that there's an error in the course code. So yeah, so we get the course code and we check to see if there's an error. Okay, so let's do that. I haven't done this with you, right? Really, we haven't done this? You guys sure? Don't let me go ahead if we've done this. All right, let's do it then. All right, so the first thing we're going to do is we're going to get the course code. Should capitalize that. Get the course code, and the thing is, I don't like those arrows. Where's it? I wish I had, I don't know, man. Can't see. Whatever. Walaikum salam. So, what we have to do is we have to check that the course code is correct. And so we have a if statement, or it could be a while. Let's do it as a while statement, actually. So that the course code length. You okay? Has to be 8, because if it's not 8, it's an error. So we can check that with a len function. We've got a len function that goes with our strings. So that's easy. So what I'm doing is I'm just looking at the code here to see what we need to do. We need to get this course code, we get that, but if the course code is bad, we have to give an error message. So that's what this is for. So if it's bad, we're going to give an error message and we're going to get the course code again. So we could do that by putting another arrow, actually. So if the course code is bad, we're going to go and get it again. I wonder if I can, yeah. So that's why that is there. So this would be a false. And if it's true, we can just continue on. So if the course code is equal to 8, we continue on. And so what we continue on with is after the course code, we get the number of students. So now we start into a loop. And that loop is going to be with the Sentinel. So the Sentinel is going to be the, what is it? The number of students in the section. So we could maybe get the number of students in the section. That would be a good thing to do. Let's do that. Let's get, oh, not that, sorry. Let's get the number of students in the section. So that'd be another one of these. So what is that called? It's called enter number of students. Let's just say get student number. And now if that number is negative, then we get out of the loop. So we need to have another one of these, which is going to control the loop. This is where we enter the loop. So that's going to be there. Be ideal if we could, yeah, anyways. So what we're going to say here is the student number, student's num is bigger than 0. It must be bigger than 0 for us to stay in the loop. If it is bigger than 0, then we stay in the loop. Otherwise, we continue on. So actually staying in the loop would be, we're going to go out this way to the side, I think, and we're going to come back to that. Or we can go down. So either way is all right. So we're going to, but we will get the student number, and we're going to add that student number to a total. Oh my gosh, we should have initialized the total at the start. So that would be, sorry, it's a bad time of the day for this, isn't it? Every time you do that, you got to join the arrows back up. So I don't like doing these flow charts. A lot of fiddling around, but you know, apparently we have to do them. So all right, so the total is equal to 0, then we get the student's number. If the student's number is bigger than 0, so this would be the true thing. Well, if it is, then we add that total to the total number. And then we just get the number again. And so that would be just an arrow going back to the get student number. Oh, for goodness sake. I don't know what's going on here. So and if the student number is not bigger than 0, then we go and do something else, which is we finish and we print things out. So that would be here where we print the total number. Whatever that is, print the total and the number of sections. Okay, so I have missed something out, right? Because we have to do the count. So we print the total and the count. So actually here, when we initialize the total, we should also initialize the count. So I need to do that there. Let's put that up. Total equals 0, but we also have to do the count. Count equals 0. And because, so I can either I can put it in here because it's not controlling the loop. So I think that's it. Sorry, it's a bit of a messing around, but okay, so it's not quite done because we have to goodness sake. I'm just trying to stretch out the thing and it's give me an arrow. Arrow, really? Oh, well, obviously, if I keep doing the same thing, I'll keep getting the same result. So I don't want to do that. It's because of the particular shape of the, yeah, there we go. That's what I should have done in the first place. That's it. So there's, I think that will work. Sorry, it's a bit ugly with the arrows. I don't know if I can do anything about the format of the arrows. Probably there's something here that we can do. The style of the arrows, yeah. Because they're kind of ugly. Curved. Oh, yeah. Not waypoints. Rounded. Does that make any difference? No. Goodness gracious. What did it do? It deleted my arrow. That's freaking awesome, wasn't it? I am not an expert on using this drawing software. Arrows, they're the worst arrows I've ever used, these ones. You gotta be kidding me. Anyways, there's no doubt there's a way of doing the format that I haven't been able to see. If I played around with it, I could probably figure it out. But anyway, I don't want to spend too much time on that. I think the thing is okay. We got a false. Suppose we should have a true down here. And likewise here, if it's bigger than 0, then this would be the true side. And this would be the false side. And yeah, that's, so you can tell it's a loop because we've got our arrow going back. Okay, let's make it into Python code. X1. Okay. So get course code. How you do that is just, yeah. So anytime you want to do something like that. Well, also we can use the notes that we've got here. Please indicate course code. So we can use that. I'm just going to copy it and paste it in there. Not that, not that one. The other up in the other Python. So that would be course code is equal to, and this is just an input. We don't need to use the int because the course code is not an integer. The course code is a string. So we can just do that like that. Oh, for goodness sake. So we say that we're going to put that in a loop. So we test to see if the length is, actually while. Is it must be equal to 8. So as long as it's not equal to 8, we're just going to print an error. So there's an error message for us. We don't have to guess what that is. The error message is there in the here it is. So you can take that error message and so we can do that. And then we'll just ask them to print the thing. So we need the course code to get the length. So I'm going to take this, just copy it and paste it in there. And then I'm going to take the entire line of code and put it there. So this is our error trapping. That doesn't allow them to put, so that takes care of this thing here, where they said a code which was the wrong length. So then we have a loop which does this other stuff. And if you look at that, oh, it's a good thing we looked at this, right? We need to increment we need to initialize our totals. So we should do that there. We can do that here. Count equals 0. And total, is it just total? Total. Yeah, total is equal 0. And then we have a while loop, which is, this is a Sentinel loop. So while the value of the course code, well, course code is bigger than 0. I'm pretty sure that's what we had in our, yeah, students. Oh, it's not course code. Sorry, it's a different thing. Sorry, good thing I looked there, right? It's not course code. It's, we have to get the number of students. So that's another one, right? So students number, right? Students number takes a value of, this is an integer. So we're going to convert the input to an integer. And the input is this, enter the number of students. Now the problem is this section 1. The section 1 is actually going to be related to the count. So we're going to remove the section 1. I'm just going to highlight it and I'm going to replace it with double quotes. And I'm going to use the double quotes to insert a number in there. The number will have to be converted to a string, and the number will be the count. But 0 is kind of a bad one to start with, so I'll add 1 to it. Whoa. All right. And then what we do is we add the count. So we add to the count and we add to the total. The total is going to be equal to the the total is going to be equal to the total plus the students number, right? Well, we call it student number here, so that's okay. As long as we call it the same thing every time, then that will work. And then the count. Again, I'm going to do the copy and paste. And the reason I'm doing the copy and paste is that way I can know that I get the same value every time. So we add those together. And then all we have to do is get the student's number again, because that's the thing controlling the loop. That's it, I think. Let's look at our, so this actually helped us out. There's a couple of things that I forgot as I was typing along, and I saw, oh, I need to do that initializing. So I went back there and did the initializing. Oh, I need to work with students number, not just with totals. So I had to go back and do that. So anyways, we're going along. We've done all this and we've actually got to there. And now we can print the totals. The print the totals is if this is outside the loop. So that's why the false. And so we can go and finish the loop. And this is where we've got a print. And we can see what we've got as a print by checking our what we're supposed to be printing is here. Just copy that and put it into the print in a string. Oops, what happened? And again, I've got some numbers that I'm supposed to have here. So I'm going to replace those numbers with string and numbers here. That's got to be replaced with a string. So the number of sections is the count. So count, that's the number of sections. Should have called it section instead of count, right? The number of students was student number. That's the total number, right? So actually this is total. And then actually we have to not put this like that, right? It has to be the course code. So at least we don't have to convert it to a string. So we can just put in there the course code. So that would be, course code is this one. Course code, this is supposed to be student number. Oh my gosh, that while loop. This is the course, this is where we're using course code, yeah. Okay, so hopefully that makes some sense. Let's look at it and see what's happening. We read and ask them for the course code. We check to make sure the course code is okay. If it's not, then they get an error and they have to enter again. If it is okay, we're not going to do this because this only happens if the course code length isn't 8. Then we increment our totals. Then we get the number of students for the first section. And we keep getting for each section and we add the the number of students to the total. Then we can print it out at the end. We only print it out at the end. Let's run it and see. Okay, well, just run then when you're ready. What happens? Why it's give it a different name. There we go. So first course code. Oh, well, I should know. Somebody's saying, sir, what's the use of exclamation mark after the len? The exclamation mark stands for not, and the exclamation mark only works with the equal sign. You could use equal equal, but if you did use equal equal, it would have to be the other way around. We would say while not len equals equal 8. So we don't want, if it's 8, it's good. And so we wouldn't be saying, oh, that's a problem, it's 8. It's only a problem if it's not, if the length isn't 8. So the exclamation mark stands for not, and that's why we do that. So good question. Right. So we're going to run this and see how that works. So check. Let's try this one, the one at the bottom, because it's got the error codes in it. Oh. So if we try INFS1101, that should give us this error code. Yeah, our error code is the same as their error code. So now we're going to put in the correct one. 02. So this one here should be 8 long. If you can see, it's 8 long, and so we shouldn't get the error again. So yeah, now we've moved on to this thing here, right? So you can see it when we did the error, when it was the wrong number. When it's the right number, that's working. 25, section 2, 17, section 3, 22, section 4, 19, and section 5, 0. So if we look at our code, it has to be bigger than 0. As soon as it's not bigger than 0, we should come out of the loop and print the total. So let's just see if that works. 0. Yeah, we come out of the loop and we print the total 83 students with 4 sections. Okay. So sorry, I kind of just barged through that. Any questions? And my apologies. I just realized I just looked up and saw you guys. I haven't been looking at you. I'm sorry, I've been in a hurry. But maybe you had some questions? No? Is it okay? Is that speed okay? Yes. All right. Because I'm trying to get through it quickly. All right. So that was run 1. If we're going to change it, done that. Oh, so this one, what we do with run 2 is we find the number of sections where there's 20 or more students. I don't think I'm going to do a flow chart on this because that flow chart was just so ugly with those terrible arrows. I just wasn't enjoying that. So what I'm just going to do is, well, what if we wanted to find how many classes have 20 or more students? You do that with an if statement, but you're going to have to do it inside the loop. Okay, and so it's a count. So we're going to have a variable that we set to 0 at the start, and then we're going to have to add to it, but only if the condition is true. So it's really quite easy to implement. We just do it like this. In our totals, we're going to say here, I'll just call it 20. And we set that equal to 0. And then inside the while loop, very first thing in the while loop, we're just going to put an if the number of students. So copy that. If that number is bigger than or equal to 0, then we can add 1 to 20. So we can just add 1 to it. Now, I didn't use the number 20 because you can't use a number for a variable. You can't start a variable with a number. So this is just a count, but it's a count only if the condition is true. Only if the number of students is more than 20, not 0, 20. Only if the number of students is more than 20, then we're going to add 1 to this. Then we can print that out. How does it want to do it? 1 sections have at least 20 students. So that's not too hard. I'm going to put another print statement here. One of these sections have 20. So we have to change this number here to be 20. So I'm going to replace that. Oh, well, we don't need this thing at this. If I do that, it's right at the very start, right? So I can just do it here. So this would just be 20. Oh, it's a string. I mean, it's a number. So we're going to have to convert it to a string. That's it. So that will show how many has at least 20 students. Let's run it again and see. Oh. Let's look at them. So this time we got the so we're running this sample run. INFS1101. The number of students in section 1, 25. In section 2 is 17. We use a negative number. Hopefully we've got our, and one of these sections has at least 20 students. 42 sitting. Yeah, so that's working fine. All right, so just to go back and explain what did we do, we had the same thing as we had before. We wanted to do a count, but we only wanted to count if a certain condition was true. So before we got into the loop, we set the count value, 20 is a count, by the way. We set that to 0. Then inside the loop, we have an if statement right at the start, and we're not going to do this at the end of the loop. We do it right at the start. Must be before we read the student number again. We check to see if we got a value that's more than 20. If it is, we add to the count. It's okay? Anybody doesn't understand? What's happened there? Okay. The average age is like the same problem. We've done average age so many times. I might leave you with that and just have a look at lab 11 because we'll kind of run out of time. Is that all right? If I'll leave lab 8, because this thing is going to be the same. We're going to do the if age is bigger than 18, then add 1 to the adult. So exercise 4 is the same as exercise 2. And we've done average before. So there's nothing in exercises 3 and 4 that we haven't done. Exercise 4, you're just going to check the age. If the age is bigger than 18, then you add 1 to the adult count. So that would be the same as here. So you'd have something here instead of 20, you'd say adults is equal to 0. If the age is bigger than 18, bigger than or equal to 18, then add 1 to the adults. So it's the same thing. You do it in the same way. And in that, you're going to do a count 0, a total 0. At the end, you're going to do an average. So the average is equal to the total divided by the count. But we've done that lots of times. So I don't know that doing that again is going to make much difference. I would, except we don't really have much time, right? So the next one I want to look at then, I guess, is lab 11. See if there's anything in there that might be useful to us. Okay. Oh. I don't think this is going to be in the quiz, so it's kind of fun though. So what do you want to do? Go back and finish lab 10. I don't think this is going to be in the quiz because it's a new idea, which is modular division. Modular division, what you do is you get the remainder. I can just show you in this table so you get it though, but see the idea here. 7 doesn't go evenly into 34, right? 4 times 7 is 28. 5 times 7 is 35. That sound right? So 34 divided by 7. That's going to be equal to 4 and 6 over 7. 4 and 6 sevenths. You could convert 6 sevenths to a decimal. I don't know exactly what it is, but you know it's going to be a big number, like 8.8 something or other, 0.83 something like that. You don't have to do it. You don't have to calculate it. All right, so I'm just telling you that that's the number. So if that's what this is equal to, right? This looks similar, right? But this is integer division. That will be equal to 4, and we cross that bit out, and we just leave it as 4. So if we wanted to know just how many times it will go in, we do that. Now we've got this other thing, which looks like this, and it's kind of related. And what that means is all we do is we take the 6 and we remove the 7 from it. This one is going to be equal to 6. Does that make sense? 6, but not divided by 7. Okay? The remainder. What this does is it gives us the remainder. This is the remainder. So modular division gives us the remainder. So looking at this thing. So 34 mod 7, the remainder is 6 because 7 will go into 34 4 times with a remainder of 6. And so the remainder is 6. All we care about is, when we do modulo, all we care about is the remainder. Does that make sense? You don't need a calculator to do that, I don't think. And anyways, the computer's going to do it for you. You're just going to write 34 like that, and it'll work. But let me show you a trick here. So let's take a number 35 and divide it by 5. And what do we get as our remainder? So 35 divided by 5, that's equal to 7, and our remainder of 0 over 5. So our remainder is 0. So modular is going to be 0. So that's cool. That's how we can tell, we can find out if something is divisible by some other number to give it, to work out evenly as we do it. So one way of finding out, so you can take any number, x modular 2, and see if it's equal to 0. If it's equal to 0, then that is an even number. And if it's not, then it's odd. So all the numbers that are divisible by 2, this is how we find out that it's divisible by 2. All the numbers that are divisible by 5, I just talked about 5, right? We do this equal 0. That means that it's divisible by 5. If it's not equal to 0, then it's not divisible by 5. Does that make sense? Now if you do modulo 2, the answer is either going to be 0 or 1, 0 or 1, 0 or 1. 1 means it's odd, 0 means it's even. 4 mod 2. 2 goes into 4 2 times with no remainder. That's equal to 0, right? 3 mod 2. 2 goes into 3 1 time with a remainder of 1. And 7 mod 2. 2 goes into 7 3 times with a remainder of 1. Get the idea? 8 mod 2. 2 goes into that 4 times, no remainder. So it's very easy to use the mod. Very good for computer people because it'll give you, you can convert an even number to 0. You can convert an odd number to 1s. And computers like 0s and 1s, right? But you can also tell any other numbers like this, is it divisible by 5? Is it any number, right? So you could use this to calculate prime numbers. You could use it for all kinds of nifty things. And so that's what's doing here. Well, you guys help me. What's going to be the result of this? 12 mod 6. Did you say 0? Yes. Sorry, I can't really hear you very well. But yes, you said 0, and that's correct, right? What about 100 mod 12? All right, so 12. Okay, I don't know. We might not remember our 12 times table, but 12 times 8, you might remember that's equal to 96, right? And 12 times 9, that's equal to 108. So 100 is in between those two, right? So 100 does not divide by 12 evenly. There's going to be, what you're going to get is 100 divided by 12 is going to give us 8 and a remainder of 4 over 12, right? Because it's going to give us 96 and there's a remainder of 4. And so when we say 100 mod 12, the answer is going to be 4 because there's a remainder of 4. Because we get, when you multiply 12 by 8, you get 96. That's 4 less than 100. So your remainder is going to be 4. Does that make sense? No? All right. That's okay. The next one, 66 mod 11. Yes. There's no remainder. So that's all we're looking for, is we're looking for the remainder. We see when something is evenly divided, and we see when something isn't evenly divided. This is the remainder. What's left after the even division? So here, this one here is trying to find out if something is divisible by 5. So if we put in the number 55, we get 0. If we put in the number 50, we get 0. Put the number 51, we don't get. Don't want to draw a flow chart. I'm kind of. You guys okay with me if I don't draw another flow chart for tonight? That it takes so much time. But we can, the even odd thing, I think that's worth doing. So we put in a number and we see if it's even or we see if it's odd. We do the modular division by 2. If the result is 0, then it's even. Else it's odd, right? There's only 2 choices. Because it's binary. There's only 2 choices. It's either even or it's odd. So that's a really, really nice one. even or odd, that asks the user to enter a positive number. And so if they don't enter, so that's going to be a Sentinel loop. We're going to count the number of evens and we're going to count the number of odds. This is really nice. So let's do this one, but we're going to do it without a flowchart because we're kind of running out of time. So let's do that. And we'll just call this even odd. I can't even spell my own name, right? Okay, and so we need to count the number of evens. So we need to start out with 0, and we need to count the number of odds. So we need to start out with 0. And we're going to use the Sentinel loop. So we're going to read a value. Oh, what's the value? How we do that, right? We're going to enter a number. That's how we read a value. So we're going to read a value. So we can just say num takes that value. It's going to be an integer value. And our prompt is going to be this, enter value. And so the number is not allowed to be negative. I think it said, well, the number is positive, right? Positive. So as long as it's bigger than or equal to 0, that's positive. Then we're going to check to see if it's even or odd. How do we check to see if it's even or odd? Very easy. If the number mod 2 is equal to 0, there's our check of even or odd, right? So if the number mod 2 is equal to 0, I did it wrong. That's why you're looking at it strange. Because I did it wrong. All right, equals 0, right? If it is, then we have to add 1 to the evens. So we're going to say the evens gets added to. All right, now, because there's only 2 things that can happen, it's either going to be even or it's going to be odd. This is Boolean. That's how zeros and ones work, right? And so we know that we can use an else. You can't do that with if we did this with 5 or something like that, but we can do it with this one. So this one's nice. And so that's going to give our odds. Odds are going to be added to 1. That's it. There's our program, basically. All we have to do is make sure that our loop continues. So we copy that and put that in our loop. And enter. Then we can say how many evens and how many odds. So that's nice and it's easy. I hope you like that one. So we're going to have a print there. And we're just going to print the thing that's at the end, which I just copied. And number 3 needs to be replaced by evens.